Hi Ashton, we're working on math lesson 1 in our new module today. So we wrapped up division of fractions in module 3. Now we're moving on to module 4, which you can find in your math book on page 103. And it's lesson 1, add and subtract multi-digit decimals. Okay, so I'm going to flip my camera around and go ahead and get started. Hopefully by the end of today's lesson you should be able to add and subtract multi-digit decimals to the thousandths with or without a model. Okay, so we're going to start out with a model to begin here today. Okay, Step It Out says the 10 by 10 grid represents one whole. There are 100 squares, so each square represents 0.01 or 1/100th of the whole. Okay, so if we were finding the sum of 0.13 1300ths plus 0.58 5800ths using a 10 by 10 grid, how can you represent 0.13 on the grid? Okay, well, you know that 1300ths means that is going to be one entire row of our column. Now you can shade in with a colored pencil like me, or just use your regular pencil. So there's my 1/10, 0.1, 1/10. Now I have 300ths more. So I'm going to continue and shade in my next 3, like so. Okay? So to answer the question that we have here, what did I do? How can I represent this? I can shade one entire row, and I'm going to write 3/10 of another row. Okay. Now it says, how can you represent 0.58 on the grid, 5800ths? Okay, so there's a couple different ways that you can do this. I'm going to use a different colored pencil for this one. What I'm going to start out by doing is, I'm going to start out and say, okay, I've got 8 100ths. So if I do 1, 2, 3, 4, 5, 6, 7, that would be 700ths. Okay, but I know I have one more hundredth that I need to fill in. I'm going to hold on to that in my head for a minute. I know now that I have, excuse me, 5/10ths more. So I'm going to shade 5/10ths more, which is going to be 5 more rows, remembering that I only shaded in 7 of the tenths here, so I'm going to need to add 1 more tenth at the end of it. So I'm going to shade down 1, 2, 3, 4, 5 rows, each square in each row. And I need to shade 1 more in to show my 5800ths. So right now I have 10, 20, 30, 40, 50, 1, 2, 3, 4, 5, 6, 7, that's 57. So to make 5800ths, it would look like this, with just 1 more in the next row. Okay? So I kind of jumped ahead here. How can I represent 5800ths on the grid? I would need 5 full rows plus 8 additional squares. Okay, how many total squares are shaded now? All right, well, that's easy for me to see now that I've got a completed grid here. I can count total rows. So this is 10, 20, 30, 40, 50, 60, 70, and 1 more. So there's 71 squares shaded. So 1300ths plus 5800ths is 0 and 7100ths. Okay. Now, you probably could have just said to yourself, well, I know 13 plus 58 is 71. And you're right, because adding decimals is similar to adding whole numbers. But you must first write the numbers so that like places are aligned. So what we're saying is if this decimal, for example, only had 0.5, we would need to make sure that the decimal points are lined up properly. Okay? We'll see an example of that right here in this next problem. While at a grocery store, Robert bought 26/100 pound of red grapes and 34/100 pound of green grapes. How many total pounds of grapes did Robert buy? Well, this little grid here that we have, this table helps us to line up the decimals in an appropriate way. So 26/100 is already written, so now I could add 34/100 like so. Okay? If we're adding from right to left like we normally would do, 6 plus 4 is 10. 1 plus 2 is 3. 3 plus 3 is 6. And we have 0.60. Okay? So the question says, did you need to regroup? Yes, we did. Right here. Yes. We regrouped 10 from the hundredths place. Ten hundredths, really we should say. We had 10 hundredths from the hundredths place to the tenths. Okay, Robert bought how many pound of grapes then? Well, he bought 0.60, so we would say he bought 6/10 pound of grapes. Okay? All right. Moving forward. On the next page, page 104, it says find the difference of 42/100 minus 19/100 using a 10 by 10 grid. How can you represent 42/100 on the grid? How can you represent subtracting 19/100? Okay, so I'm going to grab my colored pencils again. Sorry, I just need to do a little shuffling here. So if I'm using my colored pencils to help me with this problem, it would say we're looking to find the difference between 42/100 and 19/100 using their grid. How can you represent 42/100 on the grid, and then how can you represent subtracting 19/100? So I have a different problem than I did when I was adding. When I first added, I colored one of my numbers blue, one of my numbers orange, and I added up my total. You can't really do that on a grid like this when you're subtracting, so I'm going to shade what I have, my larger number first, which is 42/100, which will be 4 completed rows plus 2 more in a 5th row. So 1, 2, 3, 4. I'll shade those rows completely. Plus my additional 2/10. 41, 42. All right. Now, I'm wondering how can you represent subtracting 19/100? Well, if I had just done regular pencil, you could do something like maybe erase them, or but I like to visually be able to see how much I started with and how many I'm taking away. So I'm going to draw X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay? So I took away my 19, and what I'm left with is going to be obviously my answer, however many remain. So how can I represent this on the grid? I could shade 4 rows plus an additional 2. 2 squares in another. All right. How can I represent subtracting the 19? It's easy. I'll just X out 19 squares. Okay. So my remaining squares are going to be my answer. Now I can tell here I've got 2 full rows with no X's in them. 1, 2, so that's 20. Plus 1 up here, 21, and 2 more down here, that's 23. 23 squares remaining. So 42/100 minus 19/100 is simply 0.23. Just like if I was subtracting 42 wholes minus 19 wholes, I would get 23. Okay? Number 4 says, a cardinal weighs 1.5 ounces. Find the difference in ounces between the weights of a cardinal and a bluebird. The weight of a bluebird is shown. Okay, so we have to refer here over to our image, and the bluebird weighs 1 900 ounces, 1 900 ounces, where the cardinal weighs 1 1/2 or 1.5 ounces. So the first thing you need to ask yourself is, what number is bigger? Is 1 5/10 bigger, or is 1.09 bigger? Okay. If we think about 1.5, it's only got 2 digits with 1 decimal point, whereas this number has 3 digits and a decimal point. But we have to look at the place value of the digits. This 5 is larger than this 0. So if I'm going to subtract here to find the difference, I have to put my larger number first, not the number that has the most digits, the number that has the biggest value. So I'm going to put 1.5 here, and I'm going to put 1.09 there. And the reason why I did that is because I need to make sure that my decimal points are aligned, my bigger number's on top. Now the problem with this is I'm missing a digit here, so I can simply add a 0 without changing the value of that number. 5/10 is equivalent to 50 hundredths, so I can do that. Okay. Now I'm going to subtract 1 50 hundredths minus 1 9 hundredths. I do have to regroup one time, and I'm left with 0 41 hundredths. Okay, so the subtraction problem that I wrote was 1 5/10 minus 1 9 hundredths. Alright, so the weight of my bluebird is 41 ounces. 41 hundredths of an ounce. Okay. Alright, down below here, Julia has $1 for a snack. She buys an apple for 49 cents. How much does she have left after buying the apple? Okay, so we would take what we've done so far. We have $1 minus the amount of the apple, 0 49 hundredths of a dollar, like so, 49 cents. Okay. Now, you could do this in a number of ways. You could do it with a grid, like we showed up above. You could do it in a small table where we could line everything up by place value. You could think about what you already know about money. Okay, 49 cents is only 1 penny away from 50 cents, and another 50 cents would get you up to an even dollar. So I think you could probably do this using mental math. $1 minus 49 cents would be written as 51 cents, which is 0 and 51. 0 and 51. 51 cents. Okay? Number 2, a group of friends spent $31.95 on movie tickets and $12.54 on refreshments. How much money did they spend in all? Okay? Again, very important to make sure that you're lining your decimal points up correctly. This is the number one way that kids get problems mixed up when it comes to decimals, is lining up your decimal points incorrectly. So we have $31.95 plus the amount that they spent on refreshments, which is $12.54. And hopefully you and I both get the same answer, which is $44.49. Okay? All right, Ashton, it's that time. Now I'm going to ask you to try these problems on your own, page 105, and I will pause the video and I will fill in my answers so that you can do a quick check after you've completed these questions on your own. Okay? Make sure that you're completing them on your own and not just waiting for me to unpause the video. Okay? Okay, Ashton, here you can see the responses for the first 6 questions or so. So take a moment and look at those answers, see how they match up and compare against yours, so you can kind of monitor how you're doing. You can feel free to pause this if you need a little bit longer to look at those answers. And here's numbers 7 through 11 down at the bottom. Same thing, take a moment and compare that with what you've got. And if you have any questions, as always, please feel free to log in today from 2:30 to 3 and touch base if something's not making sense or if you just feel like you're not following along all that well. Okay? Now, Ashton, you can skip page 106, all right, if you want to. You can put an X through it or just skip it. And the next thing that you'll be completing for math is page 107 and 108, which is the lesson 4.1 practice and homework. So that'll be due by Friday and have that wrapped up by then. Okay? That's 107 and 108 in your math book. Okay? All right, Ashton, that's all for now. And feel free to reach out if you have any questions. And please do your best to submit some type of evidence so that I can see your completed work so that I know that you're with me. Okay? Thanks, Ashton, and have a good day.